What if I told you that one of Africa's most elegant birds of prey was being silently poisoned, not by hunters or habitat loss, but by something invisible in the water? Picture this: a vast, shimmering wetland under the African sun. Reeds sway in the breeze, frogs croak in the shallows, and high above, a sleek brown raptor glides on broad wings. This is the African Marsh Harrier, a master of the marshes, hunting with silent precision. But just a few decades ago, this bird was vanishing. Not from guns, not from deforestation, but from a threat no one could see. Its population was collapsing, and for years, no one knew why. The harrier was being poisoned, slowly and systematically, by a pesticide so pervasive it had seeped into the very fabric of its home. The story of how scientists uncovered this silent killer, and how they fought to bring the harrier back, is one of the most urgent ecological detective stories of our time. It all started with a mystery. Researchers in the wetlands of Kenya, Zambia, and South Africa began noticing something strange. Marsh harriers, once common, were becoming rare, nests were failing, eggs weren't hatching. In some areas, the birds had disappeared entirely. At first, scientists suspected the usual culprits: habitat drainage, human disturbance, or climate shifts. But the evidence didn't fit. The wetlands were still intact. The harriers had plenty of food. Something else was happening, something subtler and far more sinister. They began testing the birds, the water, the soil, and what they found shocked them. Traces of a potent pesticide, one not even designed for use near wetlands, were showing up in lethal concentrations. This chemical, originally created to protect crops, was washing into the marshes from nearby farms. It was accumulating in the fish and frogs the harriers ate, and it was attacking the birds in the most vulnerable way possible, by weakening their eggs, disrupting their hormones, and shutting down their ability to reproduce. The harriers weren't being shot or starved, they were being sterilized. To understand how this happened, we need to look at the life of the Marsh Harrier itself. These birds are wetland specialists. They nest deep in the reeds, hunt over open water, and rely on a diet rich in small aquatic animals. That intimate connection to the water is what makes them so vulnerable. When pesticides run off from agricultural fields, they don't just disappear. They sink into the water, bind to sediment, and enter the food chain. Small organisms absorb the toxins. Fish eat those organisms. Frogs eat the insects. And the harrier, at the top of this aquatic food chain, ends up with a concentrated dose of poison in its system. The particular pesticide in question belongs to a class known as organochlorines, chemicals that are slow to break down and highly persistent. They don't kill adult birds outright. Instead, they interfere with calcium metabolism, leading to eggshells so thin that they crack under the weight of the incubating parent. In other cases, the chemicals mimic hormones, causing developmental defects in embryos or disrupting mating behaviors. Generation by generation, the harrier population was crumbling from within. By the time the cause was identified, the situation was critical. In several regions, local harrier populations had declined by more than 70%. Conservationists realized that to save the bird, they had to tackle the source: the flow of pesticides into the wetlands. The first step was working with farmers. Many were unaware that the chemicals they used on their fields were causing such devastation miles away. Education campaigns helped shift attitudes. Farmers were introduced to integrated pest management, using natural predators, crop rotation, and less toxic alternatives to protect their harvests. In some areas, buffer zones of native vegetation were planted along waterways to filter runoff before it reached the marshes. The second front was habitat restoration. Even with reduced pesticide use, the harriers needed safe, healthy wetlands to recover. Conservation groups partnered with governments and local communities to protect key marshland areas from drainage and development. They created artificial nesting platforms in areas where natural sites had been degraded, giving the harriers a safe place to raise their young. The third and most dramatic step was a captive breeding and release program. In regions where wild populations had been completely wiped out, scientists collected eggs from healthy populations, carefully hatched and raised chicks in protected aviaries, and then reintroduced them into restored habitats. It was painstaking work. Each bird was monitored, each release was strategic. But slowly, the harriers began to return. Over time, the results began to show. Wetlands that had fallen silent once again echoed with the calls of marsh harriers. Nesting success rates improved. In regions where the birds had been locally extinct, they were now being sighted again, hunting, courting, raising new generations. The recovery wasn't instant and it wasn't universal. In some areas, pesticide contamination remains a lingering threat. But the harriers' comeback demonstrated something profound, that even an invisible, insidious threat can be overcome with knowledge, collaboration, and persistence. The story of the African marsh harrier is more than a conservation victory. It's a warning. It shows how chemicals designed to solve one problem can create another far from the source. And it's a reminder that the health of a single species is often a barometer for the health of an entire ecosystem. When the harrier thrives, the wetlands are thriving. When it suffers, the land is speaking, if we're willing to listen. Which other species do you think are facing hidden threats like this? Share your thoughts in the comments. We might just explore your suggestion in our next video.